this is a video for class 17, even though probably no one's going to be able to watch it because I'm making this after class. But anyway, this is sample problem 6.5, and what we want to do is determine the components of the forces acting on each member of the frame shown, and I think this thing looks like one of those folding chairs. So let's figure out the big FBD of the whole thing, right? And so we draw this thing again. Something like that. And put him in here. Let's see, do I need any, so I'll put this right in there. Put the force on here, boom. That's 2,400 newtons. And we have a reaction here, and a reaction in that direction. And we have a reaction here, and that's going to be our Fy, our Ey, and our Ex. Do I need anything else? I don't think so. I call it an FBD, right? Make sure I call it there. XY. It's like a very bad looking coordinate axis. I'll take the sum of the moments. Take it about, I decided to take it about E. And let's see, so the distances that I need this distance right here, 4.8 meters. And I also need this distance right here. I think I'm about to sneeze, just so you know. Thank you. Bless you. Woo. Sneezing's weird, isn't it? Anyway. Let's see. Yeah. So we have our Fy going counterclockwise, so it's positive times 4.8. And then we have our 2,400 times our 3.6, and that equals 0. So our Fy is 1,800 newtons, right? And then the sum of the forces in the y direction, and we're going to have our Ey minus 2,400, and then plus r. Whoop, we already know this answer. So that's plus 1,800. So we get our Ey is equal to, what is that, 600? Yeah, 600. And this is up, and we said this is up, so we're clear. Now we want to start breaking the thing down. Let's see, push this guy upwards a bit. And let's see. I'm going to do this horizontal component here, this horizontal piece right here. And right about there, and right about there. And so we're going to have our 2,400 down, going down here, 2,400 newtons. And our reaction, or our force at C, is going to be along this line right there. So let's leave that as that line of action. FBD, XY. And then at this reaction right here, well, what we can write right here, let's see, am I going to do it this way? I was wrong about that. Whoops, sorry about that. This is not a two-force member. Got to remember that, not a two-force member. So there's no reason that it would be along those lines right here. All it's going to do is have a reaction upwards right here, RCY. And then there would also be a reaction in this direction right here, RCX. And so if we go over to B, it's probably going to be in the opposite direction right here, RBX. And it's going to be, this is a teeter-totter situation, right? So this one's pointing upwards, this one's coming downwards. So, and that's going to make it go this way, so it needs to go this way. So this one also will need to go downwards right here to be able to balance it out. So that's our R, B, Y. Or you could also just choose them positive and find out that that they are, and then if you get a negative answer, you could find out that you get the right answer. Okay, you find the right direction. So something I forgot to do up here, by the way, the summation of forces in the x direction. So we get R, E, X equal to 0, right? I forgot to finish that up. So on this one, some of the moments, let's take it about C. I guess I decided to take about C first. And I said, okay, this is going in the clockwise direction, so this right here, and the direct distance, I think I needed to figure that out, right? So I actually need to do a little bit of geometry right here. But actually, is this true? No. Okay, so I need to figure out what this angle is, that beta. And so that beta is going to be equal to the inverse tan of rise, which is 2.7 plus 2.7, which turns out to be 5.4, and divided by our run of 4.8, and so we get an answer of 64.19 degrees. So if you wanted to find this distance right here, which I called XBC, you'd say that XBC is going to be equal to, let's say this is the rise, so we could divide the rise 2.7 divided by the tangent to get of 64.19, and that's going to give us the run, which ends up being 2.400. And I'm sure there must be some way that we could have gotten to that easier. But that's the number that we need. No, actually, the number that we need is 3.6 minus that 2.4, because this is the 2.4, and that turns out to be 1.2. And then so that's going clockwise. This one's going counterclockwise, and that could be the thing that decided, oh, that's the direction we needed to go. And then that's the answer, right? That's the 2.4 right here. 2.4 equals 0, and I get RBY is equal to 1200 newtons, and going downwards. Some of the forces in the y direction. Upward is positive. We say that we have negative 1200 plus RCY minus 2400, and I think you could do the math yourself, that we end up with RCY is 3600 newtons upwards. Did I get that right? Yes. And if we do the sum of the forces in the x, we see that we get negative RBX plus RCX equals 0. So that's just something that we know that they're equal and opposite, right? I believe later on we're going to figure out that we're going to get 0 right in here. We could figure it out, but right now we just know that they're equal and opposite. And then we want to do the FBD of the vertical part. And at the top, we have RAY. I'm guessing it's going that direction. I'm going to guess that my RAX is coming in that direction. And okay, so we have RBY. Now this needs to be opposite from this one, right? So it goes upwards for here, RBY. And then RBX, we'll draw it as opposite from what's up above, RBX. And then we do know that the REY right here is the only one on there because we already established that REX had to be 0, so we only are drawing on. And we might even want to stick in a number right in there because we know that's going to be 600 newtons. Right? And so we take the sum of the forces in the y direction. Okay, that's all we need to do really. Sum of the forces in the y direction. And we got RAY, it's unknown. RBY, we just figured that out up here, it's 1200. And that's going upwards as drawn here, 1200. And then plus 600. So we know that we got the wrong thing, right? So we got negative 1800 newtons. Therefore, it's 1800 newtons downwards is being placed on here. And it kind of makes sense on one level because this thing pushes it down, so this one's kind of pushing down onto the thing. Other things we could do here is we could take the sum of the moments about, let's take it about B. Right here, sum of the moments about B. Or we could take it sum of the moments about A. That's the one I think that's what they did in the book. Sum of the moments about A, right, is going to be equal to 0. And if you do that, you see that you have RBX, right? RBX times 2.7, right? That's the distance right there to A. And equals 0 because there's no other moment on here. Therefore, RBX is equal to 0. And therefore, RCX is equal to 0. So we actually have all the forces now that are onto this thing. What we could do if we wanted to is to check, and I didn't leave myself enough room here, but we could check on this other member right here. Right? So this one right here was a guess. And I should spell guess the right way and write it more neatly. And we got it wrong, right? So this one's actually going downwards. So this one's actually going upwards. Right? So that's the RAY is actually coming this way. We know the RAX is equal to 0. Right? So this is also RAX is equal to 0, by the way. With the sum of the forces in the x direction, we could figure out that the RAX has to be equal to 0 as well. So RAX is equal to 0. And RBX is going to be downwards on this. And then this one is FX, FY. I said X, but I meant Y. Sorry. And what we could do here is we could take the sum of the forces in the y direction is equal to 0, right? And let's pretend we don't know this one. RAY minus RBY, which we got up here is 1200. And then this one is upwards of 1800, right? So that's plus 1800. And did I do that wrong? Oh, no, 3600. Where to go? 3600. Should be, and this should be C. Damn. Messing that thing up left and right. That should be RCY, right? So that should be 3600. Right? Equals 0. And therefore, RAY is equal to 1800 newtons upwards. But of course, this one applies to here, whereas this one applies to here. You got to be careful which one that we're referring onto the thing. But anyway, as another example, since the sample problem is also in the book, so I'm not sure the video was 100% necessary, but I made it anyway. So 14 and a half minutes. Ta-da!